afternoon to all the participants. And as Alok has in the initial opening remarks mentioned, it's an immense pleasure for us to really see today so many participants are taking part in this very serious discussions today. All of you know that on the fateful day of October 30th at 6:40, one of the suspension bridges, the oldest suspension, one of the old suspension bridges that of nearly 150 years old bridge collapsed, leading to the catastrophe and also resulting in the casualties of 135 persons, including the injuries of 180 persons. All of you are able to hear, right, Alok?
Yeah, loud and clear, loud and clear.
Volume I have to.
Yeah, and as a like
the volume of my computer.
Professor Tandon, I think you'll have to mute yourself. And we all at IS20 of the like-minded people gathered together.
No, this is not it.
And we thought that as an engineering fraternity, and it is the moral and ethical obligation towards our society, we cannot be a silent spectators. That is how this panel discussions was came into the picture. And in fact, we are very, very immensely having a pleasure in reporting to you, as Alok said in his opening remarks. 1,700 people have been participating in this. Now, the suspension bridge which collapsed in Morbi was belonging to the category of the cable supported bridges, one of the variation of the cable supported bridges. I just want to give you the background of the cable supported bridges to understand before enumerating the whole collapse of the Morbi suspension bridge itself. In India, if you really look at it, there are 4 to 5 category of cable supported bridges, and the extrados. One is the externally placed cable bridge, then the extrados bridge, then the cable stay bridge, suspension bridge, as well as in some cases we also use cable technology for the construction of bridges like arc bridges, as you can see here. Among them, the record holding bridges are
Start video. Is something coming?
Durgam Charu bridge, like that is under the extrados category bridges. It holds the record, while second Hooghly bridge is having the record of 157 meters middle span, while recently constructed signature bridge with the asymmetrical cable stay bridge with the span of 251 meter on the one side of the cantilever holds the record, while the latest Dobra Chanti bridge is a suspension bridge which holds the record for 440 meter suspension bridge, while Chana bridge is an engineering marvel, claimed to an engineering marvel which has been constructed by Afghans, holds the record for 485 meter arc bridge constructed using the cable technology. Regarding the externally placed cable bridges, a lot of development has taken place, and there are laid down guidelines. The latest one being the external tendons for bridges. There's a state-of-the-art report by the FIB bulletin. It's also called the FIB bulletin. In the country, including the bridges which are under the construction, almost 15 externally placed cable bridges are there. Coming to the extrados bridge, like we are having, including those bridges which are under the construction, nearly 30 extrados bridges in the country. Whereas recently in the IRC Council, we have approved the guidelines of the extrados bridges, as you can see here on the right side, which was a much awaited guideline which has come into picture. Similarly, there was no state-of-the-art guidelines on the design and construction of the cable stay bridge, which is under construction and also constructed together. Almost nearly around 30 cable stay bridges are there in the country. Now, coming to the today's topic of the Morbi suspension bridge failure, it's very interesting to note that the suspension bridge is the oldest form of the cable supported bridge. In fact, all of you will be surprised to know that in the country there are around 633 suspension bridges, including those bridges which have been already removed, and also those bridges which is under the construction, and also those bridges which are almost more than 100 years old can be called as a heritage structure. And most of these suspension bridges which are under construction or constructed or removed in the country are in the sub-Himalayan terrain, naturally though, where number of gorges are there and the construction of the suspension bridges have to be done. It's interesting to note again, the Kidarpur Bridge is the first motorable suspension bridge, similar to that of the Kalighat Bridge in Kolkata, which were constructed in 1822. So the suspension bridge form was constructed in India way back in 1822. And many of those bridges, as I said, almost around 50 to 60% of the bridges have been already removed, but some of the bridges are still standing. I just want to bring it to the notice of all the participants that the Punular Bridge has a significance in the sense which was the still existing oldest suspension bridge, which has been constructed in 1877 at the almost at the same time of Morbi suspension bridge. As you can see here, unlike it was almost around in fact 120 meter span. It's quite a large span, 1.5 lane motorable suspension bridge, which is unlike in Morbi suspension bridge, where people were given the tickets of 600 tickets were issued for 17 rupees or 12 rupees, and the people were in a hurry to go and like travel and experience the picnic sense over there. When this particular bridge, Punular Bridge, was designed by Albert Henry, as you can see here, and the people were not very interested or eager to go on this particular suspension bridge. They were very scared. And what the Albert Henry did is he went boating around under this particular suspension bridge and said that I'll be parading 5 elephants as a load testing. And at the same time, I'll be boating under the bridge along with my family. And he did that. And after that, the people got the confidence and started moving on that particular suspension bridge. Earlier days, in the initial stages of the suspension bridge, the pylons used to be made up of stone masonry pylons, and also the main load-bearing element, that is basically the suspension cables, were made up of I-bar chain or the iron chair, as you can see here. And also, in the earlier days, the decks used to be the unstiffened decks, whereas in the latest modern suspension bridges, normally the decks are stiffened decks. Basically, these are stiffened in the form of a truss, steel trusses, as you can see here. Now, coming to the today's topic of Morbi suspension bridge failure, we can see here this is a 230-meter overall length bridge, which was constructed way back in 1870 to 1780 by the Maharaja of Morbi. That's a Wagji Thakur constructed it, and it's almost more than 140 years old bridge. And for this particular bridge, the steel elements were bought, imported from Europe. And very important point to note, when this particular bridge was constructed, the limit of 50 people on the bridge was only 15 number of bridge, keeping in view due to the weight, the bridge should not sway, and the sway should not lead to any kind of the catastrophe. So the limitation was only 15 people. In the internet, if you Google out, there are many, like the figures of the suspension bridge, Morbi suspension bridges floating around. You can see here on the right-hand side top corner, this is one of the said to be a Morbi suspension bridge, but it is not the Morbi suspension bridge, because here the lateral stabilizing cables, as you can see here. But the real Morbi suspension bridge, which was constructed, was without this lateral stabilizing cable, as you can see here. This bridge was owned by the Morbi municipality, and the contract of this bridge for the repairs as well as the maintenance was given to a contractor called Overa, and it said it has been there in the media and under the discussion. This particular bridge was repaired for 2 crores of rupees after having been closed for 6 months, and famously the owner of the Overa company, basically a clock or a watch making company, said that the people could enjoy a carefree adventure and the bridge would not need any major work for another 8 to 10 years. That's how it happened. As I said, that on the fateful day of 13th October 2002, the bridge collapsed, and it was said that the bridge had exceeded the capacity of 125 people, whereas the 500 people were on top of the bridge, as has been alleged. But I don't understand the rationality or the logic of how it has been said that the capacity of the bridge is 125 meter, when no designer or no constructor who having the experience of the design of the cable stay bridges or the cable supported bridges has done the evaluation design wise and come to the conclusion that the bridge capacity is 125 meter. But let us say that the capacity of the bridge is 125 meter, as has been said, and the number of people who were there on the bridge was 500. It's also said that the bridge violently shook before the collapse. As you can see here, just for the information, you can see in the figure, the couple of people seem to be really shaking the bridge very violently. But I'm not able to decide whether because of the shaking of the bridge, the person was looking to be shaking or the person who was initiating the shaking. That's not very clear. But anyway, it is can be seen very clearly from this the video which has been floating around. Bridge was violating or vibrating or swaying or oscillating, you can say, in a way which led to the collapse of the bridge. Very interestingly, the bridge during the forensic investigation, which has been presented to the court, which is said that the cables were rusted, that the main the load carrying element of the cables were rusted, and also the 5-member SIT committee has been formed after the collapse of the bridge, as has been alleged, as has been reported in the paper. 2 managers, 2 ticket clerks, 2 subcontractors, and 3 hired security guards were arrested, and they were under the investigation. Looking at the history of the bridge collapses in the world over the period, you can see here in the table which I have presented on the right side, there are very famous bridge collapses where more than the 135 casualties involved is only 5 numbers in the world, starting from 1275. That is the St. Sevensburg Bridge in Maastricht, which was, like a wooden bridge overloaded because for celebrating the festival, people had joined over there and the 400 people casualty was reported. Similarly, in Tokyo, 500 to 2,000 people casualties reported. And also in 1890 in Portugal, all these bridges are wooden bridges to noteworthy. And only the noteworthy bridge, which can be compared to this Morbi suspension bridge failure, is the Angers Bridge. That is a suspension bridge in France, which collapsed in 1850. And this particular bridge resulted in the casualty of 226 people, as you can see here. And also, this bridge seemed to have collapsed because of the wind vibration and also the resonance which has been caused due to the soldiers marching on the bridge. And all the earlier bridges, the collapse which has been taken place, if you really look at it, it has been the collapse has taken place because of the marching of the people, whether they are fleeing because of the army war which is taking place, or because of celebrating the festivals. All these bridges have failed if you really look at it. Unfortunately, the Morbi suspension bridge failure is the unprecedented bridge failure in our country. And I think it has resulted in the highest casualty of the bridge collapse in our country. I think it's 135 casualties has not taken place in any other bridge collapse in our country. Even in the world, if you really look at it, starting from 1,275, it ranks at 6, if you really look at it. That is the gravity of the situation which we are faced with. Now, there are a lot of unanswered questions when we come to this now. There are many questions which have been plaguing us as an engineering fraternity, as a moral obligation, ethical obligation to the society. These questions have to be answered. We thought we'll be having a panel discussion to answer this question, to seek answers to these questions. And some of the questions which can be answered during this panel discussions are, should the suspension bridges in excess of 100 years, especially those not designed and built with advanced technology, be in service, or it should be considered a heritage structure only and no proposal should be passed on that? Can high-end technology bridges like cable-supported bridges be repaired, maintained, and operated by any agency which doesn't have the experience of designing and construction of these bridges? If the proper tendering process was followed in Morbi suspension bridge repair and maintenance order, could this catastrophe be avoided? What should be the composition of SIT for such investigation? And finally, and not the least, is it not the ethical and moral responsibility of we engineering fraternity towards the society to intervene? How can we be stopped being silent spectators? These questions need to be really answered by us.
You have also thrown a question that whether such bridges should be old bridges should be continued to be used. You see, immediately after the failure of that bridge, there were umpteenth number of TV channels giving discourse on the failure, the reason for the failure, and how bridges should be looked after by eminent experts all over the country. So most of us have got our earful of advice on the bridges. And by now, through the media, we know what was the bridge. You have also explained. It's one of the longer bridges. But what was very unusual about Morbi? First of all, it's a suspension bridge. We are more accustomed to see girder bridges, steel truss bridges, and also arch bridges sometimes. In the urban areas, we seldom see suspension bridges, and we seldom see them prior to the Vidyasagar Setu came be constructed in a city itself. Now, this particular bridge was manufactured and supplied from UK. It's a bridge owned by a person, maybe gifted to him, maybe he spent the money for getting the bridge done, and it's a long span and manufactured in 1879. There was no steel at that time. All that you could get is wrought iron, which had also been called early steel, but they were usually after 1885 or so. And this was for use of a person and his courtiers. The other interesting thing, such a long bridge, almost 250 meters, half the span length of, almost half the span length of Vidyasagar Setu. And the deck width has been kept at less than 1.5 meters. I don't know if the designers had a thought that by restricting the width, they will prevent elephants from getting onto the bridge in the procession of the ruler coming through the bridge, or horses using the bridge, or maybe crowding. That's why the width was kept so low. And with such a long span and the width of only 1.5 meter, with the aspect ratio which was more than 150, the bridge did not fail over these 150 years. Perhaps this indicates we have experts in our team on wind behavior, and maybe it indicates that there were not huge wind force in that area. Otherwise, that itself should have dislodged the bridge or made it unusable. Now, because I think I will just show you by time you change the screen, okay? Now, see, this, as we said, it's a cable supported suspension bridge. Now, when talking about suspension bridge, I cannot resist the temptation of mentioning to my audience that suspension bridge is one type of bridge which is considered India's contribution to the world. Much as arch bridge is credited to the Romans, or the cantilever bridges are credited to the Chinese, it is the Indians, particularly in the Sub-Himalayan region, they have been using suspension bridge for maybe 2000 years. And the concept of a suspension bridge comes from nature. Even creepers can cross a valley, extending from trees and to create a bridge. Our ancestors, the monkeys, they could link with each other and create a bridge across the opening. And they used to cross like that. And the last ones will just hang and go to the other side. So the concept was there. And it was for human beings to adopt that by the use of a rope and then hang a deck. Now, what would have been India's contribution? The Indian contribution or the innovation was, instead of using one rope, use two ropes, give hangers, and make a deck which is horizontal, and make it extremely passable. Instead of hanging with a catenary cable and going by jhula across the bridge, we made a proper deck, and through that, people or animals could cross. So this is the Indian contribution, and therefore, no, because you can still keep that. Indian contribution, and of course, this is besides what we are going to discuss. Now, what has changed with suspension bridges with time? You know, in earlier days, these suspension bridges, even when you are using steel ropes, what used to be done, we had wire ropes and not really steel cables as we have today. And wire rope is as you use with a crane or any pulling loads. They are wire ropes with hemp or steel core. There is no defined lead, which means along with the load, expansion goes on, reducing gradually, and ultimately it becomes behaving like a structural element with a firm E value. As today, all suspension bridges have got cables that are pre-stretched during the manufacture, so that right from day one, we have a firm E value, and therefore we can analyze its structure. It is not a unpredictable material anymore. And also, the suspension bridges today are using stiffening girder, and therefore they have become stable. Earlier, without like Morbi bridge, if you walk, you feel the vibration. You feel it is going up and down. And also with movement, it will have lateral sway. So it gives you a lot of fun in crossing a bridge like that. You get excited that you are moving along with the bridge. The other important development which has happened is the anchorages. Cables cannot be connected onto a structure just like that. Earlier, what used to be done, the cable will be taken round the structure or a member through the hole, and then they will be using bulldog clamps so that the wire rope is clamped. Today, instead, you have got cast steel sockets, and you secure the cable with molten metal or even high-M sort of anchorages, and therefore they are in a much firmer situation. So the change in suspension bridge has brought in that today a much more stable structure than what used to be earlier. But all the same, those suspension bridges have survived, as moderator mentioned, that this is a bridge which has survived 150 years. And there are other bridges in Himalayas. We don't keep any record. We do not know how long they have been there, but they are still being used or they have been put to disuse. Now, this is, the problem is India is a large country, spread out, and you have got large number of such bridges. Nobody ever heard of Morbi bridge, at least in this part of the world. Nobody had heard that there is a bridge 150-year-old, 250-meter span. I have been working with suspension bridges, but I have never been about this. There are also a lot of other structures which can be vulnerable. Like we see in the brick kilns, abandoned brick kilns, you have got chimneys or abandoned power units, abandoned brick chimney, which is maybe 100-meter high. And they have got trees grown on top of them. They are deteriorating, they are falling down, but nobody takes care of them because they are in abandoned areas. And all such structures are being maintained by bodies like municipality and panchayat, who have no engineering strength, who have no management capacity. And the result has been visible in Morbi, where this heritage structure, it's an engineering marvel of such antiquity, and it has been given to a commercial organization for use as an amusement item, for people to come and enjoy the ride. It is sad that so many people paid their entry fee for a fatal plunge into the river. And some of them have suffered so much and are still recuperating. There needs to be something done about the way such structures are being handled. You see, this particular failure has given us an insight or given us an impetus to think about the future more than understand, more than finding out reasons for the failure, what we in the engineering fraternity need to do is to have an introspection and decide what can be done for in the future so that no such tragedies happen again, to blame the engineers for being careless. It is important that all such vulnerable structures must be identified national, country-wise, and we should have a register for this. We must have a knowledge that there are such structures which are vulnerable and they should be taken care of. And health monitoring of such structures, complex structures, and their rehabilitation cannot be done by all and sundry. It cannot be just tendered and given to a contractor for taking up the job. The upkeep or the maintenance should be given either to recognize academic institutions as their responsibility, or we should appoint consultants or such agencies who can take charge of a bridge and will be accountable in case there is a failure or a deterioration. In USA, firms like TY or many other consultants, they have been given charge of bridges, suspension bridges, other long span bridges. Brooklyn Bridge is also given to the original developer. Now, and again, the upkeep of such, or the responsibility for such projects should go to departments which have an engineering strength, like PWD has, like Transport Department has, like Urban Development Department has. And that must be an official action. And we must have that sort of an action embedded in our future planning. Okay, Vikash. Now, apart from the danger to all these structures which are old or which are vulnerable and which are in areas where no upkeep is there, this has also given us the care, given us the anxiety and caution for all our cable supported structures. Because failure in a cable supported bridge is instant because they are in tension. And in tension, the cable can fail, the anchorage can fail, the connectivity can fail, all sorts of failures are possible. And after the Vidyasagar Setu, after the second Hooghly Bridge, there has been a large scale development of cable supported structures. People started liking the cable supported bridges and the extra dose bridges because they are elegant, because they are aesthetically pleasing, and municipalities and city authorities have been carrying on and asking for cable supported bridges, specifically that I must get a cable stayed bridge in this state. This is true of our states, this is true of our municipalities or urban development authorities. Now, with so many hundreds of bridges constructed in recent times, by sometimes without going into all the care which has been taken, and almost universally without a thought for their maintenance, sustainability, and upkeep. It is not enough to build a bridge. It is necessary to look after the bridge, to nurture it, to take care so that it does not fail. And that is where much more care is necessary. And we must have guidelines, we must have documents, codes, and SOPs, which should be passed on to the users of the bridge by the designers, so that there is no failure of such type and no repetition of such failures. Just imagine one of the major bridges, like the Oli Bandra or the Vidyasagar Setu, failing like this in tension, in some of the hangars fail, or the anchorage. Even more dangerous is the anchorage, where you have got few cables holding the entire bridge. If one of them fails, even that record 5,000 number of Portugal Bridge will be overshadowed. And we have got to think of it. We have got to transfer this knowledge to the administrators, to the authorities, and get them to be active. Thank you very much.
Okay. So I think that although there is a SIT who's sitting on it, and they will probably determine the real cause of failure, or number of reasons which led to the failure, I thought it is better, at least as an engineer, I should try to expose before you what I think could be one of or several, a combination of several instances which have caused the failure. Of course, the first being something like 140 years old, the first thing that comes to mind is corrosion, and people have talked about the corrosion of the main tension element, which is the cable. At least on one side, it failed first, and that could be due to corrosion. Fatigue is another issue, because if you have a bridge which has lasted that long, it depends on what type of loading it has gone through. And a bridge like this will have fatigue due to wind also, because it's such a narrow bridge. From today's standard, if you ask me, it is a disproportionate as far as the dimensioning is concerned of this bridge. We should have gone for a wider bridge, or we should have gone for several other solutions, which I think it showed, Mr. Hegde, I think showed a slide where the lateral stability comes from not its own, the strength of the deck, but really some external cables which are attached to the deck. So there are many such solutions which are possible. So fatigue, according to me, can be another solution, not necessarily fatigue due to people walking over it, but fatigue due to wind. The third thing is overloading. Obviously, 100 kg per square meter with respect to, what we are designing bridges today, it is nothing and it should not have collapsed. But what is the current reduced capacity of the bridge is what we should really talk about. And finally, what I want to talk about is what is called the vandal loading. I think a couple of people before me, at least one, have already talked about it, that people have gone there to enjoy themselves, to have some fresh air and maybe jump around on the bridge, which gives them further enjoyment. But in engineering terms, when you're not walking, but you are doing something else on the bridge, which is like jumping on it, then we call this the vandal loading, for which the bridge also has to be designed. So let me go forward and tell you something about vandal loading, because this is a dynamic kind of loading. And what has happened before, the current bridge that we see, due to vandal loading or due to loading which has been caused by dynamics of the people who are even walking. It was somewhere in the year 2000 that it was really discovered as to what this is. Yeah, you can change that. Oh, okay. Good. Okay. Now I'm going to show you. Oh.
Yeah.
Okay. This is the Millennium Bridge. You can see that it is overcrowded, just like the Morbi Bridge. But you can also see that many people are taking the support of the railing because it has started vibrating in the transverse direction particularly. So when there are so many people on the bridge, you can still have a resonance of the people trying to walk across. I don't know whether you saw it carefully, but there are some people who were just look at it carefully again. I want you to see now. Please see carefully that people are really not walking the way you would walk. they've got much larger distance between their feet, and they seem to be, when the bridge moves towards in one direction, they try to stabilize themselves. Now, this type of walking, it's nothing to do with vandal loading. It is a phenomena which people realize happens when you have something which is moving. People don't walk the way they normally do. They try to stabilize themselves, and in the process, since the bridge has got a certain frequency, let us say in the transverse direction, everybody tries to step in the opposite direction to keep stable on the bridge. So this is something which was, of course, a lot of theories have come after that, but this was first discovered in the year 2000 by, scientifically saying that what it is by the people who investigated the Millennium Bridge, which is in London, and it was to celebrate the age of the millennium. So that is what it was. Now I want to show you what vandal loading is. Can you see this? Now, if you, for any, by chance, if you can, yourself and maybe 2 or 3 friends of yours, go on the bridge and try to shake it. That means, shake it means that you have to be in resonance with some frequency of the bridge. The frequency of the bridge may have maybe many. In the vertical direction, you may have many types of frequencies. In the longitudinal direction, you can have frequencies. In the torsional sense, you can have frequencies. You can also have frequencies in the lateral direction. In all these cases, every bridge has a frequency. So if you can resonate your whatsoever small force that you put, there are only 3 people and they can bring down the bridge, as you could have noticed from this one, for example. If you are doing like that, you must be enjoying yourself, taking a ride, but it can bring down the bridge. So let me show you another one, which is something similar. This is in the vertical direction. That one, what you saw, was in the transverse and torsional, but here you can see something which is in the vertical direction. You see this?
Yes.
You see how even 2 or 3 people on the bridge, on a pedestrian bridge, if they find out if they determine what the frequency is and start being resonant with it, it is just like an army marching over a bridge in unison. And they always ask the army to break the step because you may catch one of the frequencies, and then this will what is going to happen. Let me show you the last slide, which is again, end of slideshow. Okay, I think this is the end of slideshow. So I just want to say that any kind of frequency, whether it is to do with vertical frequency, lateral frequency, torsional frequency, all these can be created by a very few people on the bridge. So if you have so many people on the bridge, then you have the possibility that there are always some miscreants, or if you want to call them people who have gone on the bridge to enjoy themselves, that they can come. And especially when you have so many people on the bridge, then you have a situation much like the Millennium Bridge, which had a density more or less the same of people as existed on the Morbi Bridge at the time of collapse. But even those many number of people, once the bridge starts swaying, you have a natural tendency to find stability. And in that process, everybody is doing the same because the bridge is moving only in one direction at a time. So with that movement, you are trying to stabilize yourself, and in the process, you are creating resonance with the frequency of the bridge. So this is what happened in the Millennium Bridge, and soon after it was opened, and there were so many people on the bridge, and they found that it is shaking like that, they immediately closed it down, and it took them maybe a year before they could set it right by putting dampers in order to reduce the frequency or rather the amplitude, etc., of the vibration. How to do it? I think that when we are talking about bridges which are 150 years old, not only should we check all the things which my previous colleagues have mentioned, but you should also make sure that you are not going to end up with somebody in the middle of the night going there when there is no ticket to be sold before you enter the bridge, but they start making it vibrate the way you saw it is being done by just a handful of people, and you can get a collapse. So this is also necessary, that according to me, these bridges should be closed and they should be treated as heritage structures. And it has got so much of significance that you have one Maharaja who has two palaces across which he wants to travel by himself. I mean, it is really meant for that purpose. It is not meant for people to, go and enjoy and maybe even do what is called the vandal loading. Okay, thank you very much.
Thank you. Thank you. Thank you, Professor Tandon. I think you have so beautifully explained about this vandal loading by way of your demonstration of millennium. It was a millennium bridge, perhaps.
First one.
And
First one.
also, yeah, the first one. And also, I think like in this particular case, the bridge was repaired using the 2 crore rupees, as has been claimed by the owner of Avera company. And when they do the repair, as you rightly said, the capacity of rating of the bridges should have been done. The elements, the load-bearing elements, especially the suspension cables and the suspenders, should have been checked for the fatigue capability, as we have explained. And also, perhaps after doing the condition survey, and some designers should have got involved in that to decide what is the load capacity of the bridge. They have been saying that it can carry 125 people, but what is the rationale? Whether anybody has done the design analysis to arrive at 125? And also, after having done the condition survey, as you rightly said, should have been checked for the natural frequency. Perhaps should have been provided the stabilizing cable, lateral stabilizing cable, as the slenderness of this bridge is very high. Aspect ratio is very high. I think you have explained all those things as a structural, how structural response should have been taken care of in the repairing which was done. I think that's very interesting. And also you have sort of concluded by saying that it should be maintained as a heritage structure. Even to maintain as a heritage structure, if the condition survey was done properly, perhaps all these things could have been addressed, in my view. And Professor Prem Krishna, I'm just coming to you now. You have a decades of experience similar to that of our Amitabh Goshabda, and you have experience in addition in the academic field also. You have been advisor to the government departments as well as the cable supported bridge. I remember you were involved in the Haridwar cable stay bridge and many more, in fact, and an expert in wind design and construction of the wind sensitive structure. Now, I would like to highlight a couple of things. I would like to ask you, like there are almost 633 numbers of suspension bridges, of course, out of which almost 50% would have been removed by this time, may not be in existence in the country, and many of them are 100 years old. Even now, the suspension bridges, both pedestrian as well as the motorable suspension bridges, are being designed and constructed in the country. I don't see any guideline being there for this kind of bridges. In Morbi Bridge, particularly the main load-bearing element cables are said to have been corroded. That's what one of the forensic studies says, and it was not obviously repaired. As we can see here, though 2 crore rupees for the repairs was sent. Can the maintenance and repair of such bridges be done by contractor who does not have exposure and experience in design of constructing such high-end technology bridges? And would you like to highlight on that and any other issues you want to speak?
Mr. Hegde, if I may just say, both of us are going to disappear because really speaking, the break was supposed to be 10 minutes. It's already about 45 minutes or 1 hour. So
yeah, please.
if you don't mind, I will just disappear as soon as Mr. R.S. Sharma comes back.
Yeah, please carry on. Professor Prem Krishna, I think you can just start your discussion, please.
Sure. Well, thank you, Mr. Hegde. And very, very interesting presentations from Mr. Ghoshal and Professor Tandon. And as Mr. Hegde mentioned, this very large number of 631, in fact, he mentioned it a few days ago, and I was certainly surprised that there are that many cable bridges in this country. But then mostly they're hiding away in hills, you know. So maybe we don't see that many suspension bridges in this country. Because they're all small ones, and I guess they're mostly pedestrian bridges, small spans, unstiffened bridges like Morbi. So that is the broad characteristic of what we have in terms of suspension bridges. And in fact, there is no major suspension bridge in this country, if I may say so, major road bridge of a long span. There's none of that. I think the longest span that we have for a motorable bridge is 400 meters odd.
440.
440 meters.
Yeah.
In fact, if I may say, the chances of long or a number of suspension bridges coming in the country don't seem to be.
Sorry to intervene, Dr. Krishna.
Yeah.
We have some 300-meter plus bridges in Arunachal Pradesh, which are motorable class 24 loading. You know, it had been done in the last 30 years or so. A couple of them on branches of Brahmaputra and Shiung, Xiang, Lohit, etc. These are all stiffened permanent suspension bridges with cables which are, pre-stretched.
Okay. What spans are there?
If I may add, there is also a bridge in Uttarakhand, which is over 300 meters long.
No,
And-
I showed
Yes.
that. I showed that in my presentation.
Yes, that is there.
Presently the Dabri Chanti in Uttarakhand, Tehri, near
Yes.
Tehri, that is the 440 meter. I think Professor Prem Krishna, I think, I think that is there, right?
Right. So thanks, Mr. Koshal. I didn't know that many large number of suspension bridges occur, as you mentioned. And as I said, I was surprised that there were that many large number of suspension bridges. But coming to the point that larger span bridges, suspension bridges, don't have a very bright possibility in this country at this point, because the span range between 200 meters and 1100 meters is attractive for cable stayed bridges today. And 200 and below is extra dose bridges. So I think we'll have to, if we want a suspension bridge, we'll probably be thinking of spans which are larger than 1000 meters. Now, a few points which emerged from the presentation so eminently made earlier. One is about vibrations. And as I see it, vibrations can occur due to wind. Short-term vibrations can occur due to seismicity. Then they can occur due to vehicle movement. They can also occur due to vandals. And whatever be the source, I feel that for unstiffened bridges, which can take a lot of displacement, the danger to those bridges is much less, if I may say so. And even if at all, there may be small damage that may occur. I don't see bridges collapsing because of vibrations if they're unstiffened bridges. However, long-term vibrations due to wind. For example, in the Morbi bridge, there's no lateral stiffening also. So maybe vibrations have been occurring in that bridge. And it is an old bridge, it is 150 years, and therefore over the period, fatigue has also set in the cables. This is a possibility. Of course, as it has been mentioned, there's an investigating team which is looking at the facts of the matter. But this is one conjecture I have, is that possibly fatigue may have set in. So for such bridges, I would say that probably overloading is the most possible cause in which a major failure occurs. And if one of the cables failed, then of course the bridge is gone. There's no saving because it is a tension structure, as Mr. Ghoshal mentioned, and there is no indeterminacy built in. If one of the cable fails, the bridge fails. In fact, even tension structures, cable stayed in the extra dose type, there is indeterminacy in those bridges. So failure of one element will not probably cause a overall collapse of the bridge. But in a suspension bridge, there is no saving. Once the cable goes, the bridge goes. Now, also about the number of 125 that is being mentioned, I'm sure simple engineering should be able to lead us to whatever would have been the loading at that time, or what is the loading that it could have taken at this time. It should be possible to work that out. But it is not surprising that number of 125 is coming up, because in 150 years ago, I don't believe any designer would imagine that this bridge is going to take hundreds of people. It was meant for some people to cross this way or that way. So even if it was designed for 120 or 125 or 150, the designer was being generous. He probably wouldn't have thought that that many numbers will cross the bridge. The issue of guidelines not being there, very much so, very true. And it would be a good thing to have guidelines for design and construction and maintenance. And I would say maintenance and management. If in the context of the existing cable stayed bridges, suspension bridges, if somebody was to ask me what is the most urgent thing you should do, I would say, let us set up guidelines for maintenance and management of these bridges. Even the design and construction can follow later. Those will be for new bridges. But we need guidelines and some kind of a procedure that we should follow for maintaining these bridges and managing these bridges. And why I am bringing the word managing into it is because what happened at Morbi. Somebody has to manage the people who can go onto the bridge. If it is said that it cannot take more than 120 or 125 persons, no more than 125 persons should be allowed on the bridge. As simple as that. But that requires management of the bridge. So therefore, I think maintenance and management are the two things on which we should set up procedures and that we should do without delay. I take it that Professor Tandon said that they should be really used as heritage structures now, but even those will have to be maintained as heritage structures. And otherwise, even if we leave them on their own fate, they may also start failing or getting damaged in time. Of course, it is very, very important that whatever maintenance exercise has to be done and the structural audit has to be done for various elements of the bridge, the main cable, the hangers, the junctions, the anchorages, and a whole lot of critical points that are there in the bridge, that structural audit has got to be done by people who understand engineering. And also, since these are unconventional structures, people who understand a bit about them as well. People have some understanding of these cable bridges. So some backup knowledge is required by people who are going to do structural audit. I think if we let the structural audit be done with a thought that anybody can do anything, then we are going to be in trouble. So I think those are few thoughts I have to share with you. And I'll say that definitely some kind of guidelines ought to be set up. Call them guidelines, procedures, whatever word you would like to use, and that shouldn't take too much time to set up also. Of course, I'm more concerned, Hegdeji, that we will set up guidelines, but in our country, the culture of implementation of documents is not very great. We take things casually. Yes, guidelines say many things. Do we have to follow them? I want to share with you a small anecdote in 1 minute about this. As a young engineering graduate and a master's as well, I went to England and I worked with a consultancy firm called Flint and Neil. Flint and Neil are the company who made the Baha'i temple here, if you want to correlate with them. And I was asked to design some latticed steel bridges, and I was doing my calculations. And for some funny reason, I thought this instability of the top chord was not much of an issue. And I mentioned it to Dr. Flint. I said, is this also that I have to check? So he said, that is why it is there. It is there because it should be checked. So as a young man, it hit me that time, and I'm sharing that with you. So if we have guidelines or procedures and follow them and put in the engineering inputs that are required, we will not get these tragedies occurring. That is my thought at this moment. So thank you very much for the opportunity to say a few words.
Yeah, thank you, Professor Prem Krishna. There'll be a lot of questions at the end of the sessions. I'm sure that you'll be able to take the questions at the end. And I still, Professor Prem Krishna, what I see is this bridge was supposed to have designed for 15 persons when this bridge was designed, as per the, if you go through the history of this particular bridge. Now it is said that it can take this 125 people. I do not understand, without coming to a, doing the condition survey after 150 years and also doing some sort of an analysis, how can one come to a conclusion that this bridge can take 125? There's no evidence or the record of anybody doing the calculations and the analysis to arrive at that kind of a figure. Yeah. But it has been said, that I'm at loss to understand that, and we will debate that as we go on.
I agree with you.
Yeah,
as I said, a calculation will show what it can take.
Yes,
but I'm glad you mentioned it was designed for 15 people.
Yes, that's what it was said. It was said. And Dr. Nalathambi, I'm coming to you now, and you have worked in military engineering services, being a postgraduate in structural engineering from University of Anna University, basically, and you worked a number of years there, and during your service in the military, you have installed the bridges at a fast rate, fast track bridges, because that is required, like the Bailey bridges and other steel bridges. You installed that, and those bridges are, like only for the purpose of some temporary purposes. Normally, it is installed, and you have the experience of that. And what do you say? And also, I have seen that you have written a number of papers. Couple of papers I have come across which has been written by you. You have expressed your anguish, rightly so, at the catastrophe which has taken place, and on the basis of your military experience in installation of such bridges, what you have got to say on the collapse which has taken place, and what are your views on the government actions? Can you just throw some light?
Good evening, all of you. I hope you can hear me, sir.
Yes, perfectly.
Okay. You all aware, for any eventuality, we bank on army engineers who quickly construct bridge or many other things for the temporary requirement to be overcome. I am being an army officer. I got trained in the bridges during my service, even the young officer. I joined after my post-graduation in structural engineering. I joined army. So I was very keen to learn about bridge launching. So in fact, I topped that bridge course that time. So it is a very complex conditions. You can construct residential buildings in a slow or fast pace with the precast also. But bridges are something special. It is not like a regular structure. So when you are constructing, you have to have always in your mind where that center of gravity and the forces going to act. Otherwise, it will make you to it put you in trouble just by collapsing. We have launched a Bailey bridge with the tower construction or swinging Bailey, like different bridges we used to construct according to the space requirement. But until unless you know the force reactions or the control over that, then only we can able to complete the bridge in time. Though it is a very temporary feel, but it's not so easy. We call that the person who is controlling everything and launch is not a project manager, is a bridge commander, because he has to command everybody and make sure that the bridge is launched in the limited time. If required, we are in the war also, we require to be launched in a very fast time. And the whenever you are launching this bridge, you have to have always back calculations. Where is the support? Where are the center of gravity is acting? Where it is going to launch on other side, etc. The small miscalculation lead to a serious collapse. Now we come to the larger bridge. This is small span, large bridge, and we have been constructing a footbridge also at the thing. Any light bridge, that is a weightless bridge, because we wanted to reduce the cost of the constructions and improve the increase the efficiency. When you reduce the weight, then it automatically becomes a flexible bridge. That is, the stiffness of the bridge is reduced. The natural frequency omega equal to k by m. When the mass is reduced and it becomes the frequency is getting increased. Whenever the natural frequency and the bridge vibrating frequency matches, resonance occurs, so that your bridge vibrates not just in a U form, it vibrates in a wavy form. So the wavy form, you will not know where that exactly the maximum peak load going to come. So when that wavy form combined with the other effect, we always make a load combinations with the dead load, live load, wind load, all those things, some combination or others. But we presume all those loads are going to act in a manner, but it's not necessary. The research now shows all those codal provision also may go wrong at some time, not every time, at some time. If that is the case, it is a very vulnerable, but of course, there are a lot of softwares available now to predict each, like a moving loads on a bridge. The load moves at one location to other location, how all other members are get activated. When that is the case, we can use a software to find out each string of the footbridge should have been checked. Otherwise, the string, somebody asked me, it is a steel bridge, so it can extend or ductile manner. But if it is a connection failure, the ductility is not going to come. One cable breaks, that load goes to the other, almost double or something extra, which may not be sufficient to take and yield and fail. But the connections are more important than the member calculations. One of the main bridge collapsed, the gusset plate thickness was less than the member thickness. So the failure was occurred. Subsequently, when they did all the analysis, they realized that gusset plates should have been more than the main member thickness. Sometimes you go wrong, it is very easy. Some connections in a nut bolt or the pin bolt, it can also shear and dismantle or disconnect, which causes one by one collapse, that is a sequentially collapse. So these are the principles involved in the that is a cable suspension bridge. The cable suspension bridge we always compare with the spider web. Yeah, when you think any spider web, it will never fail on its own. We can plug it or we can remove it, but the spider is the animal kingdom's the genius engineer which constructed a net like a very watery, even though it is something very simple and very flexible, but it never fails. So those kind of flexibility we have to say. At the same time, how it is going to affect that structure and it will cause reasonable things. So connection, I said, there is a one bridge called Tokomo Bridge collapsed in 1941. That was due to that they could not find out the proper reason for that bridge collapse. Because as I said, it is a wavy thing, light metal and combinations of load. We could not make out what exact reason for collapsing. Lateral load, as I said, this is the main reason for the lateral movement. As Professor Tandon explained, lateral movement, vertical movement. See, any weight less than that, it has got a very flexible. The flexible nature can vibrate in all directions. With the other load combinations, it's more dangerous. Moving loads, sudden failures, one cable sudden failure will sequential failures. At times, even in Chennai, there was a footbridge over the canal, and one fine morning, one truck has gone over that and collapsed. It is not meant for the truck with the brick load. It's not meant for that. But the people who may be aspirant to go over long distance, they just thought they will cross it and will take. Like that, the people will definitely will not realize the importance or the safety of that bridge. Even it was passed due to some function, but otherwise also there may be motorized or jeep people, the 4 feet, whatever possible, they might have been traveling. So these all the things has to be managed well, controlled well, and maintained well. Frequent visit to each, like a railway track maintenance, we need to have a proper maintenance. We have been saying global warming on every meeting and etc. But unfortunately, the thing is only in conference and not putting effect. Today we are discussing about the cable suspension bridge, and we are all concentrating on cable suspension bridge only. But there are many other things. Many residential tower in Mumbai getting collapsed, or in other metros, old buildings. But who is auditing and controlling and making safe? But in our country, it's very difficult for us to manage it. It's not only the suspension bridge. There are many other structural elements which need to be monitored and checked, audited.
Okay.
Anyway,
Thank you. I think
the
thank you.
one point, the government, what you met with our engineers, other things, the 4 decades back, as a chief engineer of a government, he got right to directly assess with the chief minister, and have a more control on this one. As of today, all the engineers' top roles were being taken by the government officials. I will not blame them, but everybody wants to show that they are only the responsible for it. If something goes wrong, then they will blame it to the other thing. Otherwise, the inauguration of the function or opening of the canal water or anything, the people of government officials are in the front. Nowhere I see any chief engineer who is the responsible for controlling the activities are not being given responsibility or not being shown in that picture. That is the kind of a responsibility today. We are as the chief engineers or responsible engineer, we are unable to put our requirement and control the things. So these are the things. I don't want to take more time, and as such, already there are many speakers spoke on the same thing. And thank you so much, sir.
Thank you, Dr. Thambi. And in fact, the Tacoma Bridge is a bridge which failed because it changed the course of the perception of the code itself. And after the failure of the Tacoma Bridge and also Ferry Bridge cooling tower failure, the concept of the wind tunnel testing and other came into the picture. Okay. It's an interesting part that to touch upon. Now,
can I add a minute?
Yes.
See, if we get resonant vibrations,
that's right,
in stiffened suspension bridges, that can be very serious. In unstiffened bridges, I don't believe it is that much of a serious issue, but in stiffened bridges, like the Tacoma, it was only on account of resonant torsional vibrations, or flutter as they call it. And it deflected by 45 degrees either side. The rotation was 45 degrees either side. That kind of a very, very high rotation before it collapsed.
Yeah.
So, resonance there can be an issue.
No, in fact, Professor Premkrishna, that changed the perception of the code itself.
Yes, yes.
The wind loading itself.
That's right. That's right. We didn't understand bridge aerodynamics before
at that particular point of time.
Yes.
And now I'm coming to the most important the part I had left to Mr. Alok Bhaumik. Alok Bhaumik, like similar to that of Professor Tandon, recently has brought out the guidelines on extra-dose bridges on behalf of the Indian Roads Congress. And that's another variation of the cables supported bridge, as I explained. And also he has been involved in the investigation of many of the bridge collapses which has been taking place in the country during the construction. Of course, it is unabated, unfortunately. And I have given him the I'm giving him the very important task of the whole today's presentation. So far, we have been discussing about the technical aspect of it, and I'll come to this the contractual and how it had to be operated and what is right and what is wrong. This sort of things I would like Alok to explain. In this particularly the unfortunate catastrophe, the repair of work was given to a clock manufacturer, as all of us are aware. In the recent, the court hearing, the High Court judge ridiculed that the contract agreement for the repair was made in only 1.5 pages. And what is your take on this tendering process in awarding such bridges? And also, I would like to talk about, like in this particular bridge, it is said that the bridge was reopened 2 months earlier than it was expected to be opened in December. Like only it's opened in October itself, without what they call it as a fitness certificate, and we engineer call it as perhaps the load testing, which has to be done. So, in view of this, what is your opinion on the responsibilities of the various stakeholders, the contract administration itself, tendering process itself, and also now the SIT has been formed now, but since 15 days, I have not heard anything progress on the SIT. What are your views on this SIT formation in such investigation? Finally, very importantly, I would like you to highlight upon, can we engineering fraternity continue to be silent spectators vis-a-vis unabated failures which has been taking place? And it's the Indian record, the bridge collapse in terms of the casualty, as you say. What is our moral and ethical responsibility towards the society, and in what way we are indebted, and how we can stop being the silent spectators? Alok, I have given you a most onerous job of this particular panel discussion. I know that you would be able to justify and give some suggestions on that.
Thank you, Hegde Saab. I think it's a tall order. Let's go one by one. First, about the role of the owner, contractor, and the consultant vis-a-vis. I will be specific to Morbi suspension bridge, but while talking about Morbi, maybe we can touch upon the generalities. So, firstly, let us understand that reportedly this work of renovation, repair, whatever you call it, is given to Oreva Group, which is actually a maker of e-bikes, maker of clocks, maker of LED bulbs, as well as street lights. And it is also, as per media reports only, I am saying that it is understood that they have subcontracted that work to another company, which is also reportedly unknown entity, which lacks technical know-how for this kind of works. And as you mentioned that as per the yesterday's newspaper, the manner in which this contract was awarded with a single bid, without inviting any tender, without floating any tender, also is now known. Now, these are all, supposed to be sort of finally proved. These are only in media reports. But be that whatever it is clear that this Oreva Group is not really in the true sense an engineering firm who have the necessary skill to repair, rehabilitate a bridge or suspension bridge of this type. It is another matter that we can debate after I finish, that at all whether a suspension bridge can be repaired to a large extent or not. That is another matter which we will discuss. But and also we understand that this contract with Oreva was given way back in 2008, and that was valid till 2017, I think about 9 years. But the bridge was continued to be operated by Oreva even after 2017, though there was no contact, till 2022 when this contract was renewed. So all these are reflection of a complete maladministration by the owner client. So firstly, I do not think a company like Oreva should have been actually given a contract like this. But at this stage, we really do not know what is the agreement of the contract. That 1.5 page you mentioned. What is the content of that? We do not know. So perhaps it will be too premature to go into further details. But one thing I would like to add here, that private companies in current scenario where with private, PPP kind of private participation, these kind of companies do come into play often in these kind of projects. And it is not only in India, but worldwide. A parallel I would draw to this is you all have heard about the collapse of Morandi Bridge in 2018 in Italy. That bridge was taken over by a famous company called Benetton, and the Benetton is basically a wool and sweater company and a global clothing empire. And they in turn gave that job to Autostrad, the company which actually ran the Morandi Bridge. And later on during the investigation, it is very clear that this company called Autostrad did not do their job due diligence, and they are responsible for the failure because of the lack of maintenance and all. Prima facie, it is pretty obvious a case of dereliction of responsibilities by the municipal corporation, because after all, they are the owner of the bridge. What happens between the owner and the contractor is only a contract, a piece of paper. So what is to be seen is what are the conditions there, but that's a matter of detail. It is basically, as Professor Prem Krishna mentioned in his talk, that it is actually a classic example of collapse of the municipal governance at local level, and it has got a long-term implication. I think Mr. Ghoshal suggested that we should take stock of all such bridges which are in the realms of municipalities, and since municipalities do not have the technical competence, so these bridges should be transferred to PWDs and other state. I have a little different view on this. Reason being that even the PWDs also are already full with the kind of projects that we have. Even they do not have the capacity. They may have a little better competence, but I also consider the fact that the municipalities have not only the stock of bridges, which is their asset, but also a huge number of buildings, and they all are in pretty bad shape. And add to it the fact that India is going to be 40% urbanized in the next few years. By 2030, India will be 40% urban, and therefore there will be a huge shift of population or increase of cities, and thereby the role of municipal corporation is going to increase leaps and bounds. Therefore, the solution is not to take out the projects from them; rather, the solution is to sort of improve their own capacity in handling this kind of delicate situation. The matter should be definitely investigated deeply by SIT and the government. And I am not too sure whether this kind of SIT formation which is there will be able to look at it in entirety, because this 5-member panel SIT, which is headed by an IAS officer, is basically, I do not know their terms of reference, but looking at the structure of the SIT, as Mr. Hegde mentioned in his opening remarks, it looks like that the focus will be essentially to find the guilty and to identify the administrative lapses, which are absolutely essential. It has to be done. But I think even the most extensive inquiry to look into these lapses and administrative fallacies will fall short if it limits itself only to identifying the scapegoats and the technical deficiencies. There is a need to look much beyond the individual actions and structural inadequacies. You have to talk or focus into the fiscal health of the civic bodies. That needs a huge improvement. You have to talk about the strengthening and procurement process of engaging the contractors and subcontractors. As Mr. Ghoshal pointed out, many of these municipal corporations do not follow the rules of inviting bids in a very procedural manner, as is done by NHAI and other state PWDs. That way, I would say that state PWDs and NHAI and ministry are much, much better. Also, there is need to be a sort of a conclusion by the such committees to improve on the technical capacities and capabilities of the civic bodies. We have to talk about to review nature of the public-private partnership, a model which is basically now increasing everywhere. Almost all the projects are in private-public mode. And one has to go into the technical details and forensic investigation of how this bridge has failed technically. I don't think this kind of committee which is formed alone should be able to go through all these aspects which I mentioned. Probably it would be good if the government of Gujarat also comes out with another hardcore technical committee whose job should not be to find a scapegoat, but to find out the real root cause of failure of this particular bridge. Because we must know, end of the day, the public, we have lost 135 lives here, and it is probably one of the most disastrous failure in the recent times in 21st century in India. No other failure has caused so many loss of lives. So therefore, I think it is very, very important to know what should be the course of action for the rest of the bridges that we have in terms of assets, and what is their state of affairs. So should I stop here, or I can cover other aspects also, if you permit me?
Yeah, I think we can, during the panel discussions, I think I would like to take some questions, and if the time permits, I think we can just go ahead. Alok, let us, I think many questions have been asked. The questions are in the domain of, how exactly the failure has taken place, and how, it is, what was the state of the technology as far as the design and construction of the suspension bridge is concerned at that point of time, 150 years. And also the questions are same, what has been addressed. Could that, the tendering process could have been better, actually, to give it to this one. What Goshalda has explained in the beginning, the maintenance of the bridge, like that also, all the things which we have discussed, in fact, have been very well expressed in the form of the questions. I think all those questions, in my opinions, have been discussed in detail. And before taking the couple of questions, if any other panelists would like to add on the discussions which have taken place so far, the panelists may do so. I think.
Yeah, I would like to. I would like to add something.
Yes.
On the so whatever has been discussed by other panelists.
Yeah.
So first, let me talk about the live load. We have heard Hegde Saab, you mentioning that as per the original design, it was for 15%. We have heard, we have heard, a media report that it should have been 125, but actually 400. We have heard Professor Tandon, who said that the design loading should be 100 kg per square meter. And if you take 100 kg per square meter for a 1.25 meter wide bridge, it comes to about, considering an average load per person of 70 kg, it would come to 415 number of pedestrians on the bridge for the design. Now, I have also done a little bit of calculation. If I go by the current code, if today I have to build a suspension bridge of 230 meter for a footbridge, as per the current code, the load intensity to be considered is 500 kg per square meter, not 100 kg per square meter. And there is no reduction. He has, Professor Tandon, in his calculation, reduced that 400 kg to 100 because of the length of the bridge. But that reduction is only permitted in case of a highway bridge where a footpath is there, which is not, where there is no congregation.
Yes.
This is not the case here.
Yes.
Now, so if I take 500 kg per square meter and do not reduce, this bridge is supposed to carry 2,000 number of person. Now, you have to, consider the fact that the bridge was designed in 1879 when the population of Morbi was 40,000 people. Today, the Morbi has a population of 9 lakhs. And therefore, it is quite obvious that at that time, probably the design would not have been done for 500 kg per square meter. But the bridge was one of the iconic bridge, which was constructed at a cost of 3.5 lakhs in 1879. And 3.5 lakhs was a huge cost at that time. So I have a serious doubt of that figure of 15 hectares which you mentioned,
Yeah.
because nobody would spend 3.5 lakhs to carry 15% with a 233 meter span. So I think the, this figure of 125 also, how, as you very rightly pointed out, how municipal corporation decided to allow not more than 125. I don't think anybody has done any investigation and calculations to arrive at that figure, which should have been done. But somebody asked in the Q&A box, what could be the probable cause of failure? My take on this subject is that in all probability, the failure cause would have been corrosion and fatigue, which is triggered by a loading of, whatever 400 people. The bridge must have, reduced its capacity because of the corrosion. Figure of 115 or 400, leave aside. But when you had 400 people, this load was maximum, and already corroded suspension cable. As Professor Prem Krishna mentioned, that the suspension bridges are quite different from rest of the type of bridges, because they are fracture critical bridges. What is fracture critical bridge? A bridge where just if one particular element, this is a non-redundant structure, a single element, if it fails, that leads to failure of the entire bridge. That is a fracture critical bridge. So suspension bridges have got a disadvantage there, that they are fracture critical bridges. And in America, in AASHTO code, for fracture critical bridges, the inspection and the construction detailing are entirely different, because the inspection requirement of a fracture critical bridge is that you have to have a provision for hands-on inspection. What is hands-on inspection? That means every such fracture critical member of the bridge, a person should be able to touch that particular component by hand entirely, which means every cable should have a rope, a walkway along with that for the entire length of the bridge. And presently, by the modern method, you see, even if you suppose have an inspection ladder, people are going there and inspecting. What do you inspect? How many people have got the competence by looking at the cable to tell whether the cable is in good condition or bad condition? Even if you open up and you see the level of corrosion, even the experts, there is no guidance world over. Forget about India. There is no guidance in any international guideline or codes to tell you how to evaluate the capacity, remaining capacity of a corroded wires. There are thousands and thousands of wires. You see some wire by opening up, you are not able to decide by looking at a fraction, 0.5% of fraction of the cable, whether the entire cable is in bad shape or in what shape. So these are issues which is, which is a serious issue. I think I entirely agree with Professor Prem Krishna's suggestion. What is needed is a guideline on maintenance, management, and inspection of these kind of bridges, which is to be, brought out, so that at least people know as to how to do it. Last point I just want to mention is, nobody has talked about, this Morbi town has been subjected to very severe 3 tragedies. This is the 3rd tragedy. But prior to that, there were 2 more tragedies. First tragedy was in 1979, where 12,000 people lost their lives because of some dam failure at Muchu. 12,000 people lost their lives from Morbi, number 1. But that has nothing to do with the bridge. But in 2001, there was a huge earthquake in which almost all entire township of Morbi was dilapidated. 300 people lost lives. And it is reported that this particular bridge also was in distress. But so far, you see, once a bridge is in distress due to such a major earthquake where 300 people lost lives in Morbi, we need to know what structural audit was done post that earthquake and what is the outcome, whether there was any dislodgement of the saddle, whether there was any issue, and after that, how that is taken into account. So these are, highly technical issues which needs an answer. And I think I'm looking forward to the SIT or technical committee to come out with all the answers to all these questions and to be given to the public so that we understand.
Yeah.
Thank you. Thank you.
One small point, can I ask? Oh, no. Kushal sir.
Yeah.
Can I just Are you on?
Yes, yes, we can hear
Okay.
you. Bachar sir.
Okay. You see, just to remove some doubts, first of all, the methodology of inspection of cables and suspension bridges are very much there. Today, you can have magnetic flux study, you can have ultrasonic study. There is MFL, you use robots to go along the cable and it can record and you can sit on the bridge and get the complete picture. So it is, their technologies are today available. Technologies have advanced. It is not that nobody can physically inspect. In a large cable stayed bridge, the main cable, vehicular bridge, there may be 500 wire ropes. And you cannot inspect that physically. It can only be inspected technologically. Number two, a lot of weightage is being given on crowd load or number of people. You see, if you consider even 400 people at 60 kg average, Indian average, it is only 24 tons. If you consider the dead load of the bridge, I think it will be 200 tons or more. So I don't think 24 ton can cause a failure in the main member like that. But the trick is somewhere else. You see, in a suspension bridge, you have the verticals, the links. Now, if there is a concentration load at any particular location, the hanger, which if corroded, either the hanger or its anchorage, that can give way. And in a suspension bridge, if suddenly there is a twist in the deck, there would be panic and there would be everybody would like to go over each other and further sort of failure will automatically be triggered. Most probably what had happened here is some of these verticals had failed because people were concentrated. And some of those hangers had failed or their connection had failed, and that has triggered the failure which has happened. The third issue you mentioned is about not handing over the bridges to PWD but strengthening the municipalities. It's a good dream, but it's a very difficult dream. India has some 20,000 or 50,000 or 20 lakhs. I don't know how many municipalities and panchayats. If you want to strengthen them technologically, it will be a very, and of this level, where they can analyze a bridge or where they can analyze a chimney. I don't think India in another 100 years will reach that sort of a financial situation. So let us be practical. If you want to maintain such structures, there should be identified bodies. In Calcutta, a lot of bridges used to be responsibility of irrigation. I commend the government that they have transferred all that to KMDA, to the Urban Development Agency and to PWD. They have taken away from the irrigation department, which does not have that structural expertise. One must see where your strength is and do accordingly. Thank you.
Thank you. Professor Prem Krishna, you wanted to.
Just very
Yes.
small points.
Yeah.
One is that, as Mr. Bhamek mentioned about the earthquake, possibly also damaged the bridge.
Yeah, Dr. Dalatambi, I think you have to mute. I think some sound is coming from your end, I think. Dr. Tambi, I think you have to mute yourself. There is some sound coming from your end. Yeah.
Of course, I don't know what kind of damage would have occurred, but generally, unless the supporting towers have got damaged because of the earthquake, it should not be a serious issue in a simply supported suspension bridge, unstiffened. Very interestingly, the longest suspension bridge is the Akashikakyo. And
now Kanakal.
Yes, no. I guess. Anyway, the span was supposed to be between towers 1990 meters.
Yeah.
And actually it is 1991.6 meters. And the reason for this 1.6 meter displacement is the Kobe earthquake. So I always say that it is only a suspension bridge which can take that kind of, misuse, if I may say, or disuse, that something changes the span by 1.6 meters and still nothing goes wrong. So my hunch is that, I don't know, I'm speaking without knowledge, that what kind of damage would have occurred to Morbi bridge because of the earthquake. The second thing that, as Mr. Ghoshal said, it could be that some hanger or some local failure took place. And because of the failure, serious bending occurred in the cable. And therefore, besides the axial force, some serious bending stresses occurred. And that combined would have meant, it could have meant the failure of the.
Hegde Saab, can I come in here for
Yeah,
just 1 minute?
yeah, please.
I just want to show, I mean, what Mr. Ghoshal said about that. Actually, I can prove that that is precisely what has happened by showing you just one slide of a photograph which I have picked up from Google. You see, I think I will change my display setting.
No, it's seen. There is no issue on that.
Okay, so if you see this is a photograph taken in 2008 of Morbi Bridge. Okay, and if you see carefully this photograph, which is taken in 2008, you can see these suspenders are not taut. They are, you can see it reflects that they are loose. You can see somewhere they are not parallel. You can see this one. If you see here, this one or this one or even here, you can see they are not taut. They are not.
Are this Morbi Bridge or
It is Morbi Bridge. It is
Okay,
Morbi
okay,
Bridge
okay.
in 2008.
Yeah.
And this itself shows that the phenomenon of bending of the suspended cable probably would have happened, because these are not taut. You can see the deck, because this is not taut. You can see there is some kind of a torsion here, there is.
Yeah.
So it means that it caused kinks in the main cable, and that kinking would have added bending stresses.
Yeah. I hope you are able to see my screen.
No, we are seeing the
Yes.
first slide, right? First slide.
Just a minute, sir. I think maybe then I will stop share and I will do it again. Okay. Maybe there is some.
No, because there was another photograph on that. It was not a Morbi Bridge.
Oh.
So we're not sure whether it was a Morbi. Yeah.
Wait. Then I think I have.
Maybe it's the third slide.
Just a minute.
Dr. Harsha is saying it's the third slide. Third one. Yeah. Then you go to the presentation mode. That's right. Yes. Yeah.
Is it coming?
It is seen, but okay, fine. I think it can be seen. You're not in the presentation mode, but it can be seen. That's okay.
Yeah.
It's okay.
So,
Yeah.
So this is what I was talking about, that, these cables in an ideal condition should have been taut. It is not. So you can see, in fact, here it is crossing even.
Yes.
And you can see here it is crossing, which indicates that, and
No,
you can see the deck.
no,
You can
no,
see
no,
the deck here.
It is not crossing. It's a visual illusion.
Yeah,
it's
crossing in the sense I'm saying,
yeah.
visual, I understand it is a visual illusion,
Yes.
but it is, in fact, it is so much that it is even, sort of not, in any view, you are supposed to get these two parallel, lines parallel. It is not there, which seems to indicate to me that because of these suspenders, but in suspension bridge, a failure of a suspender or not in taut do not mean a global failure. It only means a localized. But that may have a bending effect on the main suspension cable, which Professor was mentioning.
Another interesting point, I think Professor Prem Krishna as well as others also made deliberate upon. See, when this bridge was repaired, basically the deck was a wooden plank. The weight of the wooden plank would have been more, that the wooden plank has been replaced with the steel plate. Basically, what has been done? What is the repair they have done? They have replaced the wooden plank with the steel plate, and they have done some sort of a painting for the bridge. That's all the repair they're talking about as far as the bridge is concerned. Certainly, that would change the dynamic characteristics of the bridge. That the wooden plank would be more damping, having a more damping effect than that of the steel plate, would have become lighter. Maybe they would have thought that the weight, by replacing the wooden plank, the capacity, carrying capacity of the bridge is increased because weight of the wooden plank is more than that of the steel plate, right? That is the understanding of that. I think that's what I saw in one of the media reports also, but it would have changed entire dynamic characteristics of the bridge, basically. Would you like to throw some light on that, Professor Prem Krishna? The changing of the wooden plank to the steel plate also will aggravate the situation, in my opinion.
It will probably, but I think to me it seems that it has got fatigued. Over the years, vibrations due to wind have gone on happening, and it's I think the long-term effect of those vibrations, which seems to me to be the most likely thing. Other issues are there, and they would also be a factor, but probably not a large enough factor
Okay.
to cause a global failure. This is my hunch.
Yeah. And also,
Probably it could have increased the stiffness, but because of the steel plate, there may be some other members stretching, or it has to be checked. It could have been checked for other effect. So just
Oh,
change
you
is
see-
not wrong, but it could have been checked for other effects.
No, Hegde Saab, one
Yeah.
thing is increase from a change from wood to steel would have increased the overall load, additional load is added.
no.
if-
Wood was quite thick, wooden planks will not be as thin as that of the steel plate which has been put on top of that.
Yeah, but then one has to know whether
Yes, yeah.
changing, resulted in increase in load or not.
I think it would change the stiffness.
So, yeah.
Look,
Stiff.
The deck will become more stiff. That's perhaps all that has happened.
Yeah.
And if you make something more stiff and make it undergo very large deformations, then that is more likely to suffer. But that is the deck which should suffer, not the
Yeah.
cable. Not the cable.
So I think we have already exceeded the our given time of 6 o'clock. It has been a fascinating discussion to say.
I think Mr. Ghoshal wants to say something.
Yeah, Ghoshal Saab, I think yes.
Just one point occurred to me. When you have fixed steel plate, what is the easiest way of fixing them? Doing welding.
Correct.
And
Yes.
in the process of welding, they might have damaged even the angle on which the
Absolutely,
welder plate
absolutely.
is
Yeah. So many
Sorry,
things will.
sorry for
Yeah.
the interruption.
No. That's absolutely the point. And it changes the whole dynamic characteristics of the bridge. I know it is not so simple to change the wooden plank will be simply, putting on top of the longitudinal runners, basically. It will not be welded or something like that. And it has been a fascinating discussion, and especially with those the professional who has in excess of 2 centuries of experience, I should say. And looking back, what I see is this bridge collapse was waiting waiting to happen. Actually, all the events which have taken place from the maintenance order, repair order, from the beginning, it looks like everything is wrong. Nothing seems to be right as far as this the suspension bridge collapse, Morbi bridge collapse is concerned. And the catastrophe was really waiting for. And in fact, somebody, I think it is Mr. Sebastian Gomes, who was asked the question in the question and answer bank, that what could be the reason for the failure. I think all of us have tried to explain the reason for the failure. And this is a 150 years old bridge. Perhaps at the time of the design of this bridge, even during the construction also, the state of the art design at that particular point of time was not much advanced, to say the least. And the wire ropes were imported from Europe, especially the British. And those wire ropes may not have been maintained for 150 years. During the investigation also, it was found, forensic investigation, that male suspension cables, the load-bearing elements were corroded. At the time of the design, nobody would have checked for the wind oscillation, similar to the failure of Tacoma Bridge. Nobody would have checked for the Wandel loading, what they're talking about, the resonance, which may result into the resonance into that. Perhaps at that particular point of time, the bridge would have been designed only for the vertical load, to be precise. It would not have been designed for any other load. That is obvious from the fact that there is no lateral stabilizing cable over there. If it was designed for the lateral loads, certainly there would have been the laterally stabilizing cable. Normally for such a narrow bridge, that would be there. And any bridge which is more than 100 years, even for the railway bridges nowadays, normally we do the fatigue evaluation. If it's more than 100 years, even though the bridge is in a very good condition, if the bridge life has exceeded the 100-year, fatigue evaluation is done. A very good, seemingly good-looking bridge, seemingly a safe bridge has been abandoned. I'm aware of the case, and I think Mr. Ghoshal Saab also will vote for it. The Jubilee Bridge, it looked like to be in a very good condition. Again, another heritage bridge, in my opinion, outstanding bridge. It was abandoned after doing the fatigue evaluation. Here, nobody seems to have done the fatigue evaluation. And also looking at the video, the collapse, at the time of the collapse, what triggered seemed to have been the vibration and the swaying, the violent shaking. And I'm not sure whether the shaking is done by the people over there, or the shaking started and the people were trying to hold the side by. That is not very clear to me from the video. But it looks as if that the people was trying to shake the bridge, like what Professor Tandon has shown in case of the Millennium Bridge. That also might have triggered. Certainly, there is no doubt, not taking into account the wind loading, the wind loading, only for the vertical loading, if you consider, I think maybe it is safe for the 500 people or 125 people. If you take all those cases into consideration, 125 people capacity also, the bridge would not have been able to take. This bridge was designed, as Professor Tandon said, perhaps for the Maharaja to cross over from one side to another side to visit his palaces. And I'm sure the Maharaja would have taken care that not many people are on the bridge when he's crossing over that bridge. As I explained to you, another similar bridge, the Punular Bridge in Kerala, which is still there as a tourist attraction, that was also done at around the same time, 1877. That's a motorable suspension bridge with 1.5 lane, around 6 meter width deck. When that bridge was constructed, imagine no taker was there. The people were not prepared to go on that bridge. That was a quite wide deck bridge. The people were very careful, but these days people don't seem to be as careful as those that bridge was there. As I explained in my opening remarks, and till the time the designer Albert Henry went below the bridge, boating around with his family, and the 5 elephants were paraded on that bridge. Nobody was going on that bridge, which was designed and constructed by him. And only after the 5 elephants were paraded on the bridge, people were going on that bridge. I think that sort of a social sensibility also should be there in our people, in my opinion, if we want to avoid this kind of catastrophe in the future. And all of us are waiting, as far as the tendering process is concerned, everybody agrees here. There has to be a proper tendering processes, even for the repair and maintenance and for the heritage structures like this bridge also. And perhaps if it's more than 100 years old, I think for all these bridges, suspension bridges, which is there, has to be treated as heritage structures, and it should not be, allowed to make money by collecting the tolls. That is, I think it's going beyond one's imagination when we are faced with such catastrophes, in my opinion. And fascinating discussion again. Once again, I am very, as a moderator, I enjoyed really this discussions and learned a lot during the discussions. And if any panelist wants to say something before closing this session, I would like the final round of comments from the panelists. If it is, if anybody wants to say something.
The bridge failure can be of two nature. One is technical, one administrative. The contraction and tender conditions and what all the tests to be carried out. That is, if it is a 1 page or 5 page, that is not enough for the bridge to complete requirement. But probably they might have taken it because 100 years existing, so it may exist further. So they taken it as a very lightly, and they made a process something very inadequate process. And as you say that the contract was given to the tube light company or LED companies, but I have been experienced many of our Indian contracts have given to the non-competent person, but they have JV with Russia or some other country, and for the namesake they have a JV, but the actual work is done by these people, and it is not in a very good order, sir. This happening central government and state government as such.
Yeah, I was going to say, this, I said that earlier also, this casual approach.
Yes, sir.
In following what is already in black and white, which should be followed. If the casual approach continues, I don't know what any kind of procedure or guidelines will help. That is one part. The other is in lighter vein. Mr. Hegde said that bridge was in a good shape, it was still abundant. So for myself and Mr. Ghoshal, I will say that if, things are in good shape, they shouldn't be abundant.
Can I add something?
Yeah, Professor Alok.
Yeah, so my final, closing thoughts would be that, as you said in the beginning, that we had 633 number of suspension bridges, and maybe 50 to 60% are still remaining, which is more than 300. And all these bridges, many of them, majority of them rather, would be pretty old. So it is very likely that main cables of these existing suspension bridges would be in a moderate or advanced stage of corrosion, fatigue, etc. And though we have failure of Morbi bridge, but maybe there are near misses, or we will not know what is the stage of these bridges till it fails.
Yeah.
So my appeal to all policymakers and the PWDs and municipalities is that there should be some move to sort of inspect these bridges in a manner where we can just merely engaging somebody to do a visual inspection from the deck, taking some photographs is not an inspection. A proper thorough inspection, it may mean a little expenditure, but I think there has to be a move towards that, so that we know the state of or condition of these bridges. Thank
Yeah.
you.
Finally, the idea of organizing this panel discussion was when we had an internal discussion, especially along with Alok. We felt that so many bridge collapses have been taking place, casualties are taking place. We thought, as an engineering fraternity, as an ethical and moral responsibility, in what way we can, not being a silent spectator. That was the idea which mooted this panel discussion. In fact, it's a first step. It's an idea. It's a panel discussion. It's meant for creating an awareness among our engineering fraternity. This is also our moral and ethical responsibility. Though we are not in a position today to make any impact in terms of the decision making, but we wanted to create an awareness. I hope that the objective is served. And also going forward, the India has a lot of wide bridges, wide bridges in the sense 2 to 3 kilometer bridges. If you really look at China nowadays, and they are coming out with many suspension bridges, double-decker suspension bridges. They are finding that double-decker suspension bridges is, when I say double-decker, multimodal, multi-transport model. One at the level, one is for the highways, another is for the railways. On the very wide river, it is possible for us to have a single foundation. On single foundation, it's possible to have two type of the transportation. I think that is going to be the order of the day for a very wide bridges, because we can go, in case of the suspension bridge up to even 2 kilometers. As Professor Premakrishna said, that the Kanakal bridge in Turkey is the longest span suspension bridge. Again, it's a double-decker suspension bridge. Double-decker suspension bridge is going to be the order of the day, because even from the sustainability point of view, also it has been found out, especially in the river, the substructure and the foundation is more carbon footprint, carbon intensive compared to that of the superstructure. So it is necessary to reduce the number of foundation in creeks and very rivers. Maybe that is also one of the points. And also the multi-transport can be avoided on the single foundation, same foundation. From that point of view, I think perhaps the suspension bridges may be the order of the day. My another worry is, almost I told you that at least there are 50 to 60 suspension bridge similar to that of the Morbi bridge in the country. It is existing, especially in the sub-Himalayan terrain, unstiffened pedestrian suspension bridges without the stabilizing this one. What will be the status of that? It is for that, I think somebody has to take the responsibility of making the structural audit. And after doing the structural audit, also we'll have to have the guidelines, in my opinion, how to go about designing, maintaining this kind of the suspension bridges. I think we are able to give some sort of a message to the policymakers of this country, if they're hearing us by this panel discussion which we have done. Again, fascinating panel discussion I had. I really enjoyed. Hope all the people who are participating in these panel discussions have enjoyed similarly. And also, aware of, tomorrow if they come across a suspension bridge similar to that of this, we engineering fraternity can always warn them, this bridge is not designed for that, that sort of awareness is there among all the participants. I think we also in a way will be able to do our bit towards the society as our obligation. With these remarks, I would like to call it a day today. Thank you very much.
Thank you, Mr. Hegde, for excellent moderation of today's panel discussion. I think you are the official moderator of IAS Shakti
Thank you.
for maybe next 2 years. So thank